in numerical inequalities, another thing that we need to understand is how to deal with the modulus functions. Okay, often children make mistakes in this area. It's okay. Let us see. Let me write or start with the mod x. What do you mean by mod x? Or what is this absolute value sign? What is the purpose of this? The purpose of this modulus sign is to make the real number inside a positive value. To make it a positive value. If it is negative, you make it positive. I'll show with an example. If I have 5 here, you know 5 is already positive. So the modulus value or the absolute value of 5 is 5 only. If you have here minus 6, then it will become what? Plus 6. Right. How plus 6 comes? You assign one more minus sign. You assign one more minus sign so that it will become plus 6. In case of numbers, I don't have to write here this step. I can just skip, directly write 6. But what about the variable? A variable, you have 2 options as I said. No, actually 3 options. I can say this will be x only if x is already positive. If already positive, mod x will be equal to x only. If x is negative, likewise, you cannot see that negative sign, but that x itself is a negative value. The value of x is negative. Some children will think about x when they see x. They will look at the coefficient of x and say it's positive. No, not like that. I cannot say, if I write here x, can you say it's positive or negative? No. It is, we do not know, it can be negative or positive or 0. That's the first thing you should understand. Some children will think the coefficient of this is 1x. 1 is positive, of course, but x is not necessary, it should be positive. So if x is negative, to remove that negative, you need to put a minus x. This area, many children do not understand this. So this, then they will think this is negative number. No, it's already negative. With the addition negative, so this happens when x is negative. If x is 0, then the third option, if x is 0, the value of that function will become 0. This is the first thing that you need to understand. This classification, if you understand, to a great extent, our problem with the modulus sign will get over. Okay, now let us do some important thing to deal with the modulus function. So, I write it here like this, mod x less than 1. What do we mean by that, or how do we solve this? If mod x is less than 1, what actually x is? That's the question. Is x is 2 or x is 5 or x is 1 by 2 or 1 by 3? What number it can be? How do we deal with that? I will say that we have got 2 options here. What are the options? This x can be less than 1. You can simply remove this modulus sign if x is already positive. I said mod x will be equal to x if x is already positive. This is one option. If x is negative, suppose x is negative, how do you make it positive? Like this, minus x less than 1, like this it will become. I just want to divide a negative or multiply a negative 1 on both sides. So I'll get what? X, this will become negative 1. Please remember, whenever you multiply or divide by a negative number, this inequality will change. So this is one answer, or the next answer is this. So you have 2 answers. When x is positive, if x is positive, you get this answer. If x is negative, you get this answer. So both answer, this or this. Let us combine that. How do you combine? Minus 1 is the smallest. X is bigger than x is 1. So you can write this as minus 1 less than x less than 1. Or the solution is minus 1, 1, like this. Let us check what are the numbers which lies in between 1 and minus 1, or proper fractions. Sometimes negative numbers are also there. Negative 1 by 2, negative 1 by 3, negative 4 by 7, negative 6 by 7, 1 by 2, 1 by 3, positive numbers, all proper fractions. Proper fractions are always 1, whether it is positive or negative. When you take the modulus side, it is less than 1. So it satisfies. Suppose you put here 3, its modulus is not less than 1. This idea, this is explanation. What I want you to learn by heart is, this I am going to use to solve. So this implies, I want you to remember, this implies minus 1 less than x less than 1. Suppose I can add one more thing, mod x is less than or equal to 1 means this implies minus 1 less than or equal to x less than 1. There is equal sign, place equal sign here. That's all. Or in another way, we can write this as minus 1, 1. This is closed interval. Minus 1, 1. This is the first thing you should do. This is first thing. This is second thing that you should remember. The third thing I'll tell. With the third thing, I can start working problems. Okay. The third thing that I want to say is, if mod x is greater than 1, how do we deal? I'll explain here. Then we will write the conclusion like this. Mod x is greater than 1. Okay, let us take the two cases. If mod x equal to x, that means if it is positive. If x is positive, this means x is greater than 1. This is the first case. This is the first case. Okay, what is the second case? Second case is this one. If x is negative, then it will be minus x greater than 1. Let me switch this minus sign over there. I want x only, not minus x. So I'll get x here minus 1. Then what I should do? Inequality I should change. So I got two answers. One is this, one is this. Can we combine this? Here x is greater than 1. Here x is less than 1. They are not going to have common things. It's in a number line. One says x is greater than 1. X greater than 1 means this. The other says x less than minus 1. Minus 1 is here. X less than minus 1. So it is like this. So two different areas of the number line only. It is actually in the opposite direction. This part is excluded. So in general we can say this means the explanation is like this. So from here I will say the explanation will be, this implies what? X less than minus 1 or x greater than 1. If you write in solution set like this, you will write minus infinity to minus 1 union 1 to infinity. Likewise, you can write a conclusion. With equal sign also, it doesn't change. Only thing, closed interval comes. Suppose mod x greater than or equal to 1 means this implies x less than or equal to minus 1 or x greater than or equal to 1 or minus infinity to minus 1 closed interval, here open only anyway, union 1 to infinity. This is how you need to understand. Okay. With this help alone, please understand this properly, you will be able to do modulus functions work. Okay. At least in algebraic functions. Okay. Now let us do some questions. Then you will get some idea. Keep this in mind. Write it down. I'll use this in solving some equations. Let me copy down some questions. First question is mod x plus 3 less than or equal to 5. I am taking some textbook questions. Okay. Now this looks like what? When I see this, I should remember whom? This one. I should remember x less than or equal to 1 implies minus 1 less than or equal to x less than or equal to 1. This should come in my mind. If when I see this question, I should come less than, or this modulus part is less than. So then I will write this, using this I write minus 5 less than or equal to x plus 3 less than or equal to 5. In the place of 1, who came here? 5. Now you transfer this 3. You have to transfer to that side as well as this side. So when you transfer plus 3, it will become minus 3. Less than or equal to x less than or equal to 5 minus 3. See, I transferred plus 3 minus 3 both sides. Then what did I get? Minus 8 less than or equal to x 2. So what is the solution? Minus 8 to 2. So that's the solution. Let us do another question. Okay. Another question. Mod 3 minus x, 3 minus 5x less than 7. This also, when I remember that this one I'll remember. So minus 7 less than, let me transfer this plus 3 to the side. So minus 3. Plus 3, minus 3, here also minus 3. So minus 10 less than. Now what I should do? I should divide by this negative 3 to make it plus x. Oh, sorry, 1x. Minus 5, negative number when you divide, inequality will flip. It will change. So minus 10 by minus 5. Here x. Here 4 by minus 5. Like this it will come. So this will flip and it will come like this. So this will be what? 2 greater than x greater than minus 4 by 5. So how we write here in solution? Minus 4 by 5 comma 2. So this is the solution. Actually you should write in a better form like this. Minus 4 by 5 less than x less than 2. This is the solution. Or this is the solution. Or you can write like this. One of this will become do. Okay, let us try another question. This is the second question I did. Second question. Now we'll do another question. Another question. Mod x plus 1 greater than or equal to 3. This is that second type. I should remember what? Mod x greater than or equal to 1. What was the solution I wrote? What was the solution? X greater than or equal to 1 or x less than or equal to minus 1. The same work I'll do. So x plus 1 greater than or equal to 3 or x plus 1 less than or equal to minus 3. So using this. So from here x greater than or equal to, take to that side. So it will become 3 minus 1. Here take to other side. X is less than minus 4 means it will be minus infinity to minus 4. Closed interval, open. Union, greater than 2 means it will start with the 2. Closed interval 2 comma infinity. That's the solution. Let's just try another question. Mod 2 minus x 3x greater than or equal to 5. This is also this type only. Greater than or equal to this type. So what I do? 2 minus 3x greater than or equal to 5. 2 minus 3x less than or equal to minus 1. So take to this. So minus 3x greater than or equal to 5 minus 2 minus 3x less than or equal to. So here or is there or. Okay. So x, when you divide by negative 3, it will flip. It will be like this. So minus 1. When you divide by a minus 3. Or minus 3 when you divide x greater than or equal to 7 by 3. So the solution is minus infinity to minus 1 union 7 by 3 to infinity. Okay. This type of questions only. In most of these cases, we can do a little more advanced type question if you want. One area which I did not say is there. both side modulus variables comes. I'll speak about that later. Let me do another question. How do we deal with this case? 3 modulus 5 minus 2x greater than 7. This is a question. This is that second type. So first thing, divide this on the other side. Mod 5 minus 2x greater than 7 by 3. Then do as usual. So you can write 5 minus 2x greater than 7 by 3 or 5 minus 2x less than minus 7 by 3. If you solve this, minus 2x greater than 7 by 3 minus 5, then this will be minus 2x greater than this. When you do minus 15, right? Minus 15. So 7 minus 15 minus 8 by 3. So when you divide by minus 2, x, this will flip when you divide. So it will become 4 by 3. Here you will get minus 2x less than minus 7 by 3 minus 5. So minus 2x less than, this will become minus 15 and minus 7, minus 22 by 3. Correct now, 15, 22. So you can cancel or divide by minus 2. So x will be greater than 11 by 3 when you divide by minus 2. So what do you get? Here x less than, so this is minus infinity to 4 by 3 union 11 by 3 to infinity. So this is how we solve this one. Okay. And we have a situation like here. Suppose you get a question like this situation. This is another property which you should remember. If mod x is less than mod y, both sides it's not a real number, both are variables. If you get like this, how do you deal? What you can do is you square it. The inequality doesn't change. You can write it as x square less than y square. If there is equal sign also, you do the same thing. If mod x is greater than mod y, you can write x square greater than y square. X square, if it is equal sign is there, you can write that also. So this idea also you should remember. Okay. So we will see one situation where I'll write like this. Mod 5x, we need to solve this. Question is to solve. Mod 5x less than mod 10 minus 5x. 10 minus 5x. Yes. How do we deal? Using that, this inequality, both side variables are there. So what you do is you square on. So you can write 5x the whole square is less than 10 minus 5x the whole square. This means 25x square less than, from here you can take a 5 common factor. 5 with the square is there, so when it comes out, it will become 25. 5 is taken, then it will be 2 minus x the whole square. Can you write like that? Just to cancel this one, that's all. This cancel. It's positive numbers, I am cancelling. Positive 25 only divided, so inequality doesn't change. So x square less than, this let us expand, 4 minus 4x plus x square. Again this x square cancel, positive x square you are subtracted. So it is 0 less than 4 minus 4x. You take this 4x to this side, 0 plus 4x less than 4. So 4x less than 4. So x less than, divide by 4, positively 4 by 4. So x is less than 1. We can solve the inequality like this. If you have any questions related to this, kindly comment, we will work on that. Okay, thank you.